Welcome, everybody. My name is Hugh Peterson. I am the product manager for Standard Imaging, covering their water phantoms and also their daily and monthly QA products. Today, we're going to be talking about our dose view water phantoms. And, it's one thing we've kind of keyed on is simplifying your routine. We've kind of, for lack of better terms, we've unlocked our software to be more simplified, easier to run through, and I'll kind of touch on that as we get through that. But a couple other things first. See if I can get my PowerPoint to work. There we go. So today's webinar will be recorded, and anybody who has registered will get a link to the recording. We've got you guys on mute, but if you have questions, there's a Q&A box up on the interface for the Teams meeting that you can enter your questions in there, and I'll address those at the end. Also, if you prefer to follow along in your local language, you can turn on the live captions and then just adjust the caption language. And up in the upper bar, the toolbar, there's a more section with the 3 dots, and then you can choose your language and speech from there. Turn on live captions, and then you can select your preferred language. So feel free to do that as you see fit. And a few other things, if I can get my PowerPoint to move. There we go. Like I said, questions at the end will be answered as we get there. So, but a little bit about Standard Imaging. We're based in Middleton, Wisconsin, just outside of Madison, which is the capital city of Wisconsin. We have a very good working relationship with the University of Wisconsin and the University of Wisconsin accredited calibration lab, where we get all our ion chambers and electrometers calibrated after manufacture before they go out, as well as for repairs that come in when is needed. We were founded in 1989, and we design a full suite of QA products for radiation therapy, anything from our water phantoms, as we'll talk about today, our line of X-ray and ion chambers, our software offerings, Adaptivo and Linac View, and I am Sure 3D for patient-specific QA, and also a host of different phantoms as well. Our daily QA device, the Beam Checker Plus. So it's a full suite of QA products that Standard Imaging offers, and you can learn more about that at standardimaging.com. You can see our whole offering. But today, like I said, we're going to kind of key in on the Dose View 3D water phantom. I've got a few hardware slides, and then I'm going to jump into a quick software demo just to kind of show you just how easy the software is to use and how complete and what you'll get from using our software. It's again designed and built for uncomplicated scanning and ease of use. Something that we realize is that typically water phantoms, best case scenario after commissioning and acceptance, they're only used once a year. The best case scenario of doing your annual measurements and annual QA for the water phantom needs. So, we've kind of built our system to be able to really be robust, since it's got to have a long life, it's got to be easy to use and very accurate. So we kind of maintain that accurate and consistent positioning. We use a heavy gauge extruded aluminum frame, which maximizes that rigidity, simplifies the setup, and maintains all that reproducibility. The positioning accuracy and repeatability is within 0.1 millimeter per axis, so it is very fine as far as the drive mechanisms and what we call the robot is concerned. It allows for very quick and precise 3-point leveling. And even before the systems go out the door, we do a system test. Not only do we do a run of the motors, we burn them in for 24 hours just to make sure that they're driving correctly and accurately. But we also do a coordinate measurement at 39 different points throughout the Phantom to make sure that those points are indeed accurate, and the system maintains that accuracy of the 0.1 millimeter per axis. A few more things as far as the kind of the highlights of some of the system beyond just the tank itself and the robot scanning arms. A couple different things. The frame and interface are mechanically secured together, so that ensures that long-term integrity and accuracy. We've got a kind of small feature, but it's something that's very convenient. We have a suction drain to minimize water in the tank after you drain the tank, so you don't have any of the armature of the movement robot sitting in residual water. So you don't have to worry about oxidation or mineralization if you're not using deionized water or distilled water. So that kind of pulls that out of the tank all the way to the bottom of the floor of the tank. Then we have a fully integrated lift and reservoir cart for positioning the system under the gantry, and that makes things very convenient because it's just a quick fill from the reservoir cart that's self-contained. If you don't want the reservoir, we do have an optional lift cart only, so that's available as well. So that's certainly an option that we offer. There's also a precision positioning platform. Very hard to say. The positioning platform gives you the course rotational adjustments at 45 and 90. So if you want to rotate the tank 45 degrees to do those large field diagonal scans, you have that functionality. And you'll see on the edge of the edge of the platform there, you'll see the 3 black levers. So, and those are fine adjustment levers for the X, the Y, and rotational fine adjustment. So once you get the system kind of under the crosshairs, there's crosshairs on the bottom of the tank that help align the system. You can do very fine adjustment with those levers to move the system up to 2 centimeters, to fine tune the position. Again, not only in your X and Y position, but also that rotational as well. Gives you a little bit more accuracy to be able to, and a little more leeway to position that tank under the gantry and under the crosshairs. The system we redesigned it a couple years ago to what we call our Generation 2 or Gen 2 hardware, and it's got a little bit lower profile and it has a more compact design. It not only improves the rigidity, but it also designed to be Halcyon compatible as well as conventional C-arm Linux. So you can see it fits very well in the Halcyon bore. So it's snug, not going to lie, but still get those full-size scans for the system necessary for the Halcyon system too. So you still can do your 40 by 40 scans as necessary. We also have specific fill lines on the water phantom as well for Halcyon use, so you don't exceed the couch weight limit. So that is along the side, so it gives you the ability to fill that tank just to the right amount, so you don't exceed those couch limits. Some of the other nice features of the water phantom itself: wireless connectivity. Not only do we have a wireless pendant, which you see here shows you not only the positions of the placement of the detector in X, Y, and Z, allows you to set your origins, give you soft limits, so you don't have any danger of damaging your detectors against the wall of the Phantom, should you use larger chambers or things like that. Also gives you the ability to have probe control in 3 speeds, slow, fast, and also step mode for those 0.1 millimeter steps. Nice thing too is we also have the ability to turn the bias on and off at the pendant. I know there's a lot of situations where you go out of the room with the bias and turn the bias on, realize that something maybe not quite right, so you got to go back in the vault, and you left the bias on. You can turn it off the pendant. Small feature, but it's a very much of a convenience. So it gives you that simple setup and system configuration right from the pendant. It's, again, wireless, so you can walk around the Phantom to do your initial setup without having to be tethered to it and do any cord management. It's a very convenient that way. That onboard display shows the probe position at all times. The speeds, as I mentioned. The bias switch I mentioned. And then, additionally, between, not only is the wireless, the pendant wireless, we also have included in the system a Zigbee receiver and transmitter for wireless connectivity to the PC. So you can set up your water Phantom with the radio and have wireless communication to the wall of the vault, and then that cable goes through the wall to the PC. So you don't have a number of cables laying on the floor, connecting the system to the PC. That gives you that versatility and convenience. One thing we are have a very good history and a very good reputation for is building our electrometers. We have if you're familiar with our Max 4000 electrometer, our CDX 2000, our Supermax electrometer, which is our 2-channel electrometer. We've got a long history in very accurate electrometers, and the DOSU integrated electrometer is no different. It's a charge digitizing electrometer, so it gives you that high-speed acquisition for high-speed scanning. It's got a 10 femtocoulomb resolution, dual polarity bias voltages and independent bias voltages. So if you want to use a detector such as a diode or our scintillation detector, which doesn't use bias, you can have that off on the field detector, and the reference, if you're just using an ion chamber for the reference, you can have bias on that. So those are independent that way. We've got a very innovative and versatile detector alignment system. The nice thing is it gives you the ability to quickly set up your tank. You can set the system up probably in about 15 minutes. Fill to set up as far as your leveling and what have you. We've got an innovative detector alignment jig that you can see on the bottom left of the line of chamber holders, and we also have a wide array of chamber holders included as well. That alignment jig basically gives you visualization to make sure that as you do your runouts for your setup of the chamber at the surface, you can see that X on the end, and if it distorts in any way, if you're as you move in and out of from the center of the field, you'll know that you're not quite aligned, and you have the ability to do quick alignment there as well. And then once you are aligned, you see up in the upper right, there's a chamber mount system, which basically you set your chamber up, and that build-up cap with the line on it aligns to the line on the block. Then you just take that as you tighten that up, secure that in the holder, move that to the chamber mount in the Phantom, and it places it right at the exact point you need it for scanning. So it's a very quick and easy setup for the chamber positioning as well. So again, multiple chamber holders are included. That includes for our A28 chamber, which I'll talk about in just a second, but also diodes, larger chambers such as farmer chambers, and a host of different parallel plate chambers too, with such as the Roos or the Marcus type chambers. We have an automatic fine beam center tool in the software, which I'll touch on as well, which once you get your chamber aligned, and then you can do a fine tune to find the actual center of the beam and then reset your origin accordingly. And that can be done at multiple depths to check that leveling. Additionally, our software has functionality and integration with existing standard imaging tools such as our 1D Phantom and our Supermax and Max 4000 electrometers. The system, it's a turnkey system, so it does also include, not only all the alignment jigs and chamber holders, we do also include two of our X-ray and 828 scanning chambers. Those are 0.125 cc in volume and has a spherical collecting volume, which is nice. So there's no offsets or things like that when you're scanning in the X or Y direction. The system, because it's spherical, gives you equal measurements in both directions. Then we also have a complete offering of X-ray detectors, our ion chambers, our diodes. We have a couple of scintillation detectors too. Our scintillation detectors, some of the first in the industry, are very highly regarded, very accurate, water equivalent, 1 millimeter by 1 millimeter scanning for the W2, and 1 by 3 for the W1 for point measurements. All our chambers are built, our ion chambers are built with homogeneous Schonka C552 conductive plastic, and that includes the collector guard and the shell. So there's no high Z materials in the beam for beam perturbation, virtually invisible to the beam, and they're very, very robust. Nice thing about our chambers is they are repairable. If for some reason you might break a shell or damage them accordingly, somehow they can be repaired accordingly. And because of that quality of those chambers, we actually offer something that's unheard of in the industry, which is a 5-year warranty on those chambers. So should something go wrong that was not necessarily deemed as abuse, like breaking a shell or something like that, they can be replaced under warranty. But again, they are one of the only chambers out there that are fully repairable should something happen to them. Jumping into the software now, kind of touched on all the hardware and the components for it, but jumping into the software, about 4 years ago, we kind of went ground up and rewrote the software, rebuilt the software from scratch, just to make it much easier, much more user-friendly, and took a lot of advice from physicists using our first iteration of the software and incorporated it into the new version of the software that we offer today. It's an easy left to right, top to bottom navigation, so any kind of Windows environment you're familiar with, very easy to navigate through it. It's, again, fully integrated for our DoseView 3D and our DoseView 1D. We like to say there's no hidden features. Everything is kind of at your fingertips. There's basically only 3 tabs. There's a setup tab, a measurement tab, and an analysis tab. So everything is right there for you. Very easy to navigate through. We've got very intuitive menus as well for setting up the scan queues for that measurement and for that analysis. And I'll kind of touch on that as I kind of move into the software now. Let's take a look at that. Here's our interfaces. You can see they're very, very clean interfaces. Gives you a lot of, space to look at your scans and view your metrics and things like that. So let's take a look at that. I'm going to jump out of here and jump into the software. So as I mentioned, this is our setup, measure, and analyze. You can see the 3 tabs listed at the top. And this is the setup areas where you set up your machines and your clinics and your specific machines. So for example, I've got a Clinic SI, Clinic Standard Imaging in Middleton, my contact being Dr. Famous. I can just add those accordingly as you see fit, and I can add additional clinics. If I've a consulting physicist or a physicist that covers more than one site, they can have multiple clinics listed in their system here. And cancel that. And then, for example, if I highlight this, I have my 3 Linacs showing for this. I've got a couple of, actually it looks like 3 Elekta systems. Works for Elekta as well as it works for Varian. This particular database was from a customer that utilizes Elekta, but you see here I've got 3 Linacs, and similarly you can add your Linacs accordingly. You can name them. You have their manufacturer. We have the ability to use Accuray CyberKnife, Siemens, Elekta, Varian, etc. enter in your different energies that you might have. So pretty straightforward there too. For example, if I jump into my LINAC 5, I can see I've got 2 registered energies. I've got 6 MV and I've got 6 MeV. So that's kind of what I'm looking at there for that specific LINAC. Detectors, same thing. I can add my specific detectors, the name of the detector, who the manufacturer is. We tend to be vendor neutral here, so we don't make it easy to use other manufacturers' ion chambers, even though standard imaging X-ray chambers have much better life, and we prefer those, but we'll use anybody's. Whether it's a cylindrical or parallel plate or a diode or another type of with bias or other type without bias. And this is a nice feature, safety feature within the system, is that if you do choose a diode or you choose an other type of detector with no bias, the system won't let you turn the bias on. So you don't have to worry about damaging the diode or damaging the front end of the electrometer by applying bias to a detector that does not require bias. So just a little safety feature built into the system. But as you can see here, I've got a number of different chambers in my system. I've got a diode from PTW. I've got our A4, which is a spherical chamber, which some use as the reference detector for small fields, because it's sensitive enough where it can sit outside the field and not have to be in the field for reference measurement. I've got a couple of our A26 microchamber and our scanning chambers as well. I'm going to jump over scan queues real quick and just jump into preferences. Preferences, basically, this is where you set up your date and your time format, your decimal separators, whether they're period or commas. Obviously in the States, typically we use the period, but other places in the world tend to use commas for their decimal separators. So you can pick and choose those accordingly. Same with your CSV outputs for our exports. And then jumping back to scan queues, this is one of the nice features of the software. Very easy to set up your scan queues. I can add, and you'll see here where when I add a queue, there's basically 4 categories, which will increase as I move down the thing. But you can see things are listed as not set. So I name it, I choose whether my medium is, whether it's MV or triple F or electrons, my field definers, MLC or JAWS, or I can do SRS cones as well. If I pick electrons, my electron cone will be active. I can choose my cones. Modifiers, whether there's any wedges or cutouts, things like that. So then once I finish that, you can see here it's listed as complete. Go to my energies. For this, I just want to do 6 MV, but I can add energies down here if I want. I can pick and choose my different energies. If I have like maybe 12 MB, I can add that very easily. You see that populates here, and then I'm like, oh, I don't have 12 MB on this LINAC, so I can get rid of it just as easily. So that's my energies there. Field size, same thing. I can do my length and my width. They can be asymmetric field sizes, or in this case, I've got some populated here. For this scan set, I'm going to do a 10 by 10 and maybe a 5 by 5. And then my scan types, again, so once I have that set, I can also, like I said, if I'm doing SRS cones, I can pick circular, and then I can choose a diameter for that. But my scan types, I want to do cross-plane, in-plane, and depth. And you'll see I've got a couple new categories here, depths and CAX offsets. I can also do half scans, and the software will allow you to stitch them together in the analysis page. So if I want to do cross-plane positive and cross-plane negative half scans, I can do that. Same with in-plane as well. And then I can stitch those together into a single profile with the tool at the end. Choosing my depth, so I want to do one, I want to do one at, for this case, Dmax and 10 cm. And then my CAX offsets, I'm only going to do along the center lines, but If I want to do offsets, I can do that. I can add negative and positive positions to do offset scans as well, or off-axis scans, I should say. And then finally, there's the, I'm ready to scan now, but I can also go into my scan mode. You can see all these are listed as complete. Go into my scan mode, and this has a couple other options you can choose. You can choose my mode of scanning, either step scanning or continuous, whichever you prefer. Step obviously being, in millimeters, and continuous being millimeters per second. And then I have my overscan functionality, which is specific distance or percentage of my full width half max. I also have what we call zones. Right now it's set up for a single zone where it's a single resolution all the way across. I can choose multiple, and that gives me the ability to not only choose the size of my my zones here, but I can also have a higher resolution, say in my high gradient penumbra regions here. If I want to do, this is set to do 15 millimeters per second in the tail and the flat region, and 5 millimeters per second in those penumbra regions for a little higher higher resolution. Have that functionality set up in the system. Same with depths. Again, stepping continuous, I can force a point at Dmax to make sure that I do get a point at that Dmax position. I can set my number of zones. I can have a single zone, or I can have a couple zones if I want a higher resolution in that Dmax region. I can choose that. I can set those up. I can choose whether I want to go up or down. I can choose my start points and my end zone for the scan as well. So, but then I'm ready. You can see I'm ready to go scan here. So I've got all my my system are complete. I've got a total of 10 scans here with the profiles and the depths I'm going to do. So I can save that, and you'll see my there's my sample test scan at the bottom of the list here. I can always I can go ahead and if this one I made yesterday, I can go ahead and I can delete that, and that one's gone. I can edit, I can copy if I want to do, so you don't have to kind of reinvent the wheel. You can copy different sets. So if I wanted to kind of, I go in, I can edit things. So that's all functionality, which is in the scan queue build. I can export those as well. So if I want to move it to another PC, I can import them from another PC. So it gives you a lot of functionality within the setup. Moving on to measure, this similarly, you can see here, I've got some things that are set okay and some things in gray that need attention. Nice thing about this too, with the dose view, again, since you're only using it once a year, we have a demo mode, so you don't have to be connected to the hardware. So that's what I use for demo as well. So I can go ahead and I connect, and then I can initialize my my phantom that's not really there. So that's initialized and ready to go, and now you see that's marked as ready. My detectors, I've got my 2 A28s selected, but I can choose from my list if I want, but I'm going to stick with my A28s because those are my scanning chambers. I can choose not to use a reference detector for whatever reason you would not use a reference detector, and be ready to go there. And you can see that that's in blue and ready. Here's my electrometer. That you can see is not ready because it's still grayed out. So I can open that up, and basically I just need to choose to apply my my bias to my field of my reference. I turn that on. I want to do 300. I can zero my electrometer from here and close that up. Just to give me a little more real estate so I can kind of show you the last two things. Here's my position. I can move my chamber detector to any place in the phantom that I want. I can go to that, put in the numbers, go to that position, it'll move that chamber. I can set that as my origin if I want to. I can always go back to my origin. And here's that locate beam center I was talking about, where basically I can choose a depth if I wanted to go and do my locate beam center at a specific depth. All I then do then is click on that. It runs the scan to the 50% lines. It goes to that specific depth I choose, runs the scan out to those 50% lines, finds that exact beam center, and it will give you your cross-plane and in-plane shift to center that. Typically, it's less than a millimeter because the system sets up pretty easily. So I can go ahead and that would give you those shifts, and then you can shift that origin accordingly as well, very easily. But that's really all there is for setup for this. And then I can go to my queue. And I want to load that queue that I just made. And click on OK. And just reminding me to check on my dose rate settings, and that's something that was done in the hardware section here. You can choose your dose rate there. You can enter your dose rate, and then you can also choose your sampling times and your dwell times. But you can see here, I've got I got a blue box and I've got a black or a gray box of scans. They kind of separate them. You can see here, this is my 10 by 10 scans, and these are my 5 by 5 scans. So if you have different energies in a scan queue, if you have different field sizes, they kind of separate them so you can easily visualize where those are. And then you can pick and choose what scans you want. In this case, I want to do them all. I can zero my electrometer from here, which I already did. I can normalize. Let me go, let's see, I want to go back to 0 and 1.5. That was where I left it when I canceled out of the fine beam center. But now my depth here, so I want to go to that position down in the center. I want to normalize. I'm normalized. I'm ready to go ahead and scan. So I can just hit turn the beam on, hit the scan button, and you'll see that you have a green bar here showing you which scan is active, what the percent of completion is, etc. So this will go ahead and run in the background, and I can jump into the analyze page, just kind of show you what we've got there. I've got a few scans chosen that we've done before, some 6MV and some depth scans. But you can see here there's a number of different tools up top here. Here's some filters you can choose. I'll kind of touch on these up here, but the filters, I've got a couple different smoothing filters. I've got a boxcar and a Gaussian. I can do a point edit. So if I get like kind of a wonky point for some reason, I want to just clean that up, and smoothing didn't do that, I can edit that single point. I can normalize to a specific value. I can normalize to the center. I can do a center of the scan. So the scan is a little offset. I can center that automatically. I can do an average symmetric value from left to right hand sides. I can do a mirror from negative to positive or mirror positive to negative. I can do a flip, a 180 degree flip of the scan, and I can also do a shift. So those are available for the profiles. For the depths, similarly, I've got a couple of smoothing filters. I've got the point edit. I've got a couple of normalization tools. I've got a shift tool, and then I also have a convert to dose tool. So when you are entering your chambers into the setup library, you also put in the diameter, the inner diameter of the chamber. So when you do your dose convert, these are already all dose converted. You can see down here, if they weren't dose converted, it will give you the ionization numbers, and it'll say ion versus dose. But I can go ahead and you can see here, I can choose what protocol, whether I want to do TG51 or TRS-398 for my, and I don't know if you heard the ding. Sometimes you can hear the ding when I'm doing a webinar, sometimes not, but you do also get this dialog box. If I'm over in the analyze page and I have scans running in the background, this will just tell you, hey, those first set of scans is done. So if I go back to the measure, and you can see here that those scan sets are done, so I'm ready to move to my 5 by 5 measurements now. So I'll go ahead and do that, and now I'm moving on to my depth scan here, and then I will do the profiles. But jumping back to the analysis page, I've got five or six, or I guess 7 scans up here, showing you the different the different parameters for the scans. And I can go on to show the metrics there. Enter the metrics. I'm going to show my full width half max, the center of it, of the scans, the edge of the scans, the penumbra widths, where that central axis measurement position is, my max percentage, my minimum percentage, my flatness, my symmetries accordingly. If I want to use, this is the AAPM protocol. I have different protocols available to me for FFF or IEC. So those you can just pick and choose, and those will do your different flatness and symmetry measurements and calculations accordingly, depending on what protocol you have. But you can see again the metrics all listed there. Another thing you can do is you can actually, if you have a set of scans that you deem as your, maybe your goal data or your reference, you can set those here so you bring those scans up, those become your reference scans if you select that. And then when you come up here, you can show those reference scans. And what that does, gives you a couple different things. Not only gives you a gamma of your reference scan to a similar parameter scan. As you can see here, you can change your dose tolerance and your distance to agreement for the gammas as well. You have the tools here to kind of zoom in. And it's hard to see. Let me see if I can get in a little tighter. You'll actually visualize the, I don't see this. These are really, here we go. If I kind of hover over it, it shows the reference scan in a dotted line, and then it shows the scan in a solid line. So you can kind of do a comparison there just to see, but you can see, you check with your gammas as well. But accordingly, also you can see your metrics with your reference scan as well. So here you'll see now with the reference show reference scans turned on and selected, I can go down and see that there's actually a second line for each of my scans, and you'll see here the asterisks. The asterisks note that is actually my selected reference scan. So scan 88 is the one I chose for reference, and then scan 91, scan 105, those are being compared back to scan 91. So scan 91 has a full width half max of 33.35. The reference scan 33.33, so kind of right in line, and that kind of follows across the board for your comparisons. So asterisk means that is your reference scan, and the number below is the scan, the visualized scan on the scan window up here gives you what that selected scan is. You'll see down here too, scan 172 has 2 dashes. That means basically that was a scan that does not have a reference scan attached to it for comparison. And you'll see if I go back to my my scan data, that actually all my other ones were 10 cm depth. This one was a 5 cm depth, and that's why I didn't have a selected reference scan, because I don't have a reference scan selected for 5. So that's kind of what you've got there. And I'm moving back up now to real quick to finish up here, the different tools you have across the board. I can add my scans and clear the scans. I can save my scans as a specific scan set. So then if I want to take this, if I make this a scan set, I can always just go and select that and bring that scan set back to the front. So that's something you can always do. Here's, as I mentioned, you can merge your half scans. So if you do 2 half scans and the positive and the negative, you can stitch them together into a single scan. Something I didn't mention was the filters applied. Like here, the filters applied, I've only got it normalized at center, but if I applied any of these other filters, that would show up here as well. And here's a couple tools. I can either remove that last filter I had placed, or I can clear all filters. As I mentioned, I can open up and look at my scan sets if I have any saved. I can export my scans. If you save here, a consulting physicist or another physicist want to look at your data, then has DoseView software on another PC. You can export that in the DoseView format and import it as well. So if someone else has DoseView scans, they can bring those in also. Another nice thing that I didn't mention yet, we also have a scan import tool that allows you to import legacy scans. So if you have an older PTW or an older IBA water phantom that you're looking to replace, you can actually take that data and import it into DoseView and use that data. And you can, if you have a good set of data from that, you can set that as your reference scan from your PTW or IBA scanner. And then as you subsequent scans with the DoseView, you can compare those accordingly. So, all is not lost if you have moving from one older system to this system to a newer system. That data can be imported and used as you see fit. So that's the export and the import tools. Also for export, you'll see we have the ability to export to just about any number of the treatment planning systems: Eclipse, Monaco, Pinnacle, Rayplan from Raysearch. Again, we can export to CyberKnife if you have a CyberKnife system, the Precision treatment planning system for for your acceptance and your commissioning. You can take your scans and move those into there accordingly. We also have export into Electa's Aqua QA platform, so that's available as well. And then below you see we have the ability to, again, like I said, export it in a dose view format. You can export it in CSV if you want to do some your own analysis in Excel and do some comparison there. You can export your depth scans to PDD tables, and then you can also do a calculated TPR for getting your TPR tables for the treatment planning system. So that's a different kind of exports we've got. And finally, our reports. You have the ability of doing a couple different types of reports. One being a CSV report that you can export to CSV. And then we also do ISO-DOS PDFs as well. So that's the kind of the report system we have. Probably in the next 6 to 8 months, in the next version of the software release, we'll have PDF reports as well. So kind of more canned PDF reports for your accreditations and your audits and things like that. So that's kind of what we're looking for to add. So that's kind of the software in a nutshell. Just a quick overview, and if there's anything specific that you wanted to take a look at, you can certainly get in touch with your regional rep, and we can do kind of a more in-depth dive of the software. But this is just kind of a quick overview today. And so from there, I'm going to kind of take a look and see if we have any questions. Looks like we might. So optimize your scanning queue to save time. So basically, and I'm not sure what you mean by optimize, but being able to take your copy and edit and paste your scans. You can make a single one and then build off of those. The detector measurement, the detector orientation. It does not. The detector holder can hold, and you can mount either vertical or horizontal detectors. So the orientation does not matter. It's more a matter of the detector itself. And actually, if you see, there's the system is compatible with Halcyon and Ethos. Like I said, we updated the hardware to fit Halcyon and Ethos with our Generation 2 hardware, and the leveling basically is done. We've got the ability to do it. We've done you can do it manually with the leveling screws, and we did it with when we did testing on an Ethos. I'm sorry, Halcyon. And basically, it's a simple, kind of the same way you do the leveling with the regular C-arm. You just level it from the Phantom, so it can easily be leveling. And there's enough motion or movement in the leveling of the system to be able to account for any couch sag, because they're obviously with the Halcyon unit and the weight on the water Phantom, there's some couch sag, but you can account for that with the leveling. So, but that's looks like all the questions I've got. So let me just kind of jump back here. So again, as I mentioned, the hardware, quick summary here, very intuitive and versatile detector alignment system for that quick setup. Structurally rigid design for good repeatability and accuracy, and those 0.1 millimeter per axis positional positionings and precision. Very quick alignment and leveling of the system. Wireless functionality for ease of setup and time savings in trip hazards. A fast acquisition electrometer and independent bias. Again, mentioned it's a turnkey system. So the reservoir cart, the phantom, the chambers, all your import protocols are there as well. You know, we don't charge extra for additional treatment planning systems, things like that. It's all included. So it is a very much a turnkey system. And the software, you know, that quick queue setup and depth scans for profile scans of for all energies and modalities. Conversion of the depth scans to dose and export to PDD tables and TPR. And you know, that included export to any number of the treatment planning systems that the main treatment planning systems available today. The software, that easy left to right, top to bottom navigation, quick queue setup with very easy copy and editing functions to make quick scan capabilities. You know, a good feature in that. We call that no hidden features. Everything's kind of at your fingertips. We have the ability to choose either step or continuous with the multiple zone resolutions as well. That export to the treatment planning systems in different formats. The import functionality for that legacy scan data, again, if you have an older PDW or IBA scanner. And that very straightforward post-scan processing and metrics. You know, the nice thing about our system too is that the raw data you get out of it is very good, so there's very little post-scan processing that's necessary. So that's kind of my quick overview today. So you know, feel free to visit standardimaging.com. If you have any questions, you can email sales@standardimaging.com and they'll direct your specific email to your regional representative or your international representative, depending on where you're located. And you can also always email me with questions, hpeterson@standardimaging.com. So with that, I will bid you all a good day, good afternoon, good morning, depending on where you're located, and definitely feel free to let us know if there are any questions. Thanks very much.